The conic we're going to focus on today is parabolas. Now I know that we covered parabolas in Pre-Calculus 1, and in Pre-Calculus 1 we focused in on the vertex and this axis of symmetry. Now in Pre-Calc 2 we talk further about the parabola, and we talk about where the focus is and also where the directrix is, which is something new. Also, in Pre-Calc 1, we talked about a parabola that was a function. In this Pre-Calc 2 video, we are talking about parabolas that may be both facing up or facing down, but also facing left and right. So in the past, it's always been x squared. In this video, we're going to talk about when y is squared as well. So there's a lot of applications with the parabola. One of the applications you see every day is in the light bulbs of your cars, or the light bulbs of or the light fixtures of your flashlight, and other things in which we need to have that shape. You see them in satellite dishes. You see them in cables, like the Golden Gate Bridge. So there's lots of applications for the parabola. When we talk about the parabola, we talk about the vertex. We explain whether or not it opens up or down, now also left and right. We have the axis of symmetry. And what the axis of symmetry is, it is the value in which the distance from the left side and the right side of the parabola are the same distance, like a mirror image. It's a mirror image. And then we're now introducing the focus. So here is the focus, and with the focus, it has to be on the axis of symmetry. Also, what happens with the focus is this distance from the focus to any point on the parabola is the same distance from the focus down to the directrix. The directrix, which is here, runs perpendicular to the axis of symmetry, which is here. So since the focus is an equal distance from any point on the graph, and then from that point on the graph to the directrix, then the distance from the focus to the vertex is the same distance as the distance from the vertex to the directrix. In particular, that distance from the focus to the vertex is what we call P. So the focus in this particular example, where we are facing the parabolic shape is facing up. It's a U shape instead of an upside down U shape. And the equation for this is here, where x squared is equal to 4p times y. The focus is on the axis of symmetry, which is the y-axis, and the focus is 0, p, so the distance from the vertex to the focus is p. The axis of symmetry is the y-axis. Now, the thing that would change is if it was running upside down. So let's just draw this really quick upside down. If this was running upside down, my P now would be the same, but I would have 0, negative P. And my equation of the directrix would be y is equal to positive P, where here y is equal to negative P. The other thing that would change is you may see it as negative x squared is equal to 4py. but you may also see it as x squared is equal to negative 4py. Those are equivalent. Now let's move the parabola so it's on its side. So we're either facing left or right. If my parabolic shape is facing right, as in this case, then I know that my equation is y is going to be positive, and it's going to be squared, and 4px is what it'll equal. Notice on both of the equations in which my x is squared or my y is squared is that the side that is not squared is the side that has the 4p. It is still, p is still the distance from the x-axis, or excuse me, the distance from the vertex to the focus, or the vertex to the directrix. So my focus is now situated at p, 0, because my axis of symmetry is the y-axis. My directrix now is running parallel to the y-axis because it must be perpendicular to my axis of symmetry. As in my previous example, if I am now going in the opposite direction, like that, then this would be negative y squared is equal to 4px, or you may see it as y is equal to y squared is equal to negative 4px. Either one of these works. My vertex is still at 0, 0, but now my focus is at negative p, 0, and my directrix is x is equal to positive p. Over here, when we are facing to the right, it's opening to the right, I have x is equal to negative p, and my focus is at a positive p. When we are facing left, it is at negative p, and x is at positive p. So, for these examples, we're asked to find the focus, the directrix, and then graph the parabola. So what I do is I pay attention to who is squared, whether it's the x squared or the y squared. On A, the y is squared. So what I know for A, because the y is squared, then I know that my graph is either opening to the right or my graph is opening to the left. Because neither of the values on the left or right of the equation are negative, that means my graph must be opening to the right. So with that in mind, then I know that I have to solve for y squared. So what I need is everything that is not y squared needs to be moved to the other side of the equal sign. So I'm going to divide both sides by 2. So I've got x divided by 2 is equal to y squared. I'm just going to rewrite this as 1/2 x is equal to y squared. The reason I'm going to do that is because my equation is 4 times p times x is equal to y squared. And so I've got the y squared, I've got the x, that means this value in front of that must be equal to 4p. So 4p must equal 1/2. So p must equal 1/8. So that is the distance from the vertex to the directrix and the distance from the vertex to the focus. I guess there's only one in there. So I know that this thing is opening to the right. My axis of symmetry is y is equal to 0 because I am opening to the right. My directrix is here, and it is the distance p away from the vertex. So this is x is equal to negative 1/8. My shape is something like that. And then my focus is also a distance of p from the vertex, and so it is at the point 1/8, 0. Let's take a look at the next one. My next example, my x is squared, so that means I'm either facing up or I'm facing down, and that's because my x is the one that's squared this time. As in my previous example, there's no part of it that is negative, so that means my graph must be facing up. It's already wrote in the way that I like, which is 4py is equal to x squared. I don't have to worry about solving for x squared. So that means that 4p must equal this number 4. That means p equals 1. So my graph, here's where my vertex is. My axis of symmetry is x is equal to 0. My directrix is 1 away from this distance, 1 away from my vertex, and it's opening up. So I know it has to be below the vertex. So this is y is equal to -1. My focus also must have a distance of 1 from the vertex, so this is the point 0, 1. And there's my graph. Now, my graphs are not terribly pretty, and they don't look much different in terms of where the p is. So I just want to talk a little bit about what p is. So as p, what happens with p, if you draw these on like Desmos or you draw them by hand, as p gets larger than 1, so that means my p-value is moving away from my vertex. So as p gets larger than 1, the wider it becomes. Now mine are not drawn well, so keep that in mind. And as p gets less than 1, the skinnier they become, so the narrower they are. So my graphs, they pretty much have the same shape almost. I'm not drawing them to scale very well. That's what I'm trying to say. I'm not drawing them to scale very well. So please bear that in mind when you're graphing these, is that as my p-value gets larger, the wider my graph becomes. And as my p-value gets smaller, the narrower my graph becomes. So whichever way it's facing, I just want to say that because I'm not drawing these to scale very well today. Looking at C, what we have to do with C is we need to get it in the form of x squared or y squared equals. Now, in this case, I know that it's my y squared, so I'm going to be opening left or right. But I do have a negative this time, so because of that negative combined with the y squared, that means my graph should be opening in this direction. So I need to get this in the form of y squared is equal to 4px. It's not there yet. So I'm going to divide both sides by 3, and I get y squared is equal to -1/3 x. Now that it's in the right form, what I know is 4p is equal to -1/3. That means p is equal to -1/2. So what that tells me is that, first of all, I'm opening to the left because it's a negative p-value. And also it's telling me that this is going to be a pretty narrow parabolic shape. Of course, mine won't look that way because I'm not drawing these to scale very well. So my axis of symmetry is y equals 0. My directrix is 1/12 away from my vertex. That's where my vertex is. So my axis of symmetry is x is equal to +1/12. My vertex is also 1/12 away, or not my vertex, my focus. So my focus is at the point -1/12, 0. and my graph looks something like this. Now remember, this is a fairly skinny graph because it is, my p-value is 1/12 and it's a lot less than 1. Okay, for these, they want us to find the graph, and they also want us to find the equation of the parabolic shape and then graph it. So with any conic, I start graphing the information that I have so I can visually see which direction I'm going. So I know that this vertex is at 0, 0, and my focus is at 0, -4. So here's where my focus is. My parabolic shapes have to hug that focus, so I know that that is the shape of my graph. And if that's the shape of my graph and my focus is 4 away from the vertex, that means my directrix is also 4 away from my vertex. So my directrix is y = 4. And the reason I need that is because, remember, this distance and this distance, which is the same, that 4 is equal to my p-value. So I know that this graph is facing downwards. That means it's opening down. That means my x must be squared. So I must have x squared is equal to. Now, my graphs, the equation of my graphs is x squared is equal to 4py. That's the generic one when we are sitting at the vertex, is sitting at the origin. But my p is 4. So what I have is 4, my p-value, times y. So this equation is x squared is equal to 16y, and that is the equation of the graph. Let's take a look at the next one. The next one is my vertex again is at 0, 0. So here's where my vertex is. My focus is at 10, 0. So 10, 0 is where my focus is. So here's where my focus is. That tells me, because my parabola has to hug that focus, that I must be opening in this direction. So because my focus is a distance of 10 from the vertex, that means my directrix also must be a distance of 10 from the vertex. That means this is x is equal to -10. Now, finding the equation should be y squared is equal to 4p times x, because I'm opening to the right. My p-value is 10, and so I have y squared is equal to 4 multiplied by 10 x. Y squared is equal to 40x. And as I'm sitting here, I just realized on my previous example, because I'm opening down, I do have to have a negative on that. So to make my previous example correct, is that must be here, because I'm opening downward, is it must be x squared. X squared must be equal to -16. So because I'm opening downwards, it has to be a negative on the p. The p is negative. Okay, coming back to here, this is the equation of my graph whose vertex is at 0, 0 and whose focus is at 10, 0. Now, for the most part, we don't spend a lot of time on the x at the origin for a vertex. Most of our parabolic shapes are off of the origin. When that happens, then the equation that I get is similar to the other conics I've had for circles and what I've had for ellipses, in the fact that I have this x minus h and I have this y minus k. So those parts remain the same, that x and h go together and k and y go together. Now, when I was looking at my circles and my ellipses, HK was my center. Now, sorry, HK is where my vertex is. So my focus, if it's opening up or down, has the form H, and then I'm adding my p-value or subtracting my p-value from the K part of my vertex because my X has stabilized. The same thing is true with my directrix. Notice that my directrix is going to be y equals K minus or K plus my p-value. My axis of symmetry is going to be X is equal to H. If we are opening left or right, same thing. Notice that it is still Y and K are together and still X and H are together. My axis of symmetry is going to be Y is equal to the K value, and my vertex is going to be HK. Now this time my K is stabilized, and so my H plus P or minus P is where I'm going to find my focus. And my directrix is going to be X is equal to H plus or minus P. So let's look at a couple examples here. For A, what I'm doing is I'm looking to see for which variable is the squared variable. In this case, the squared variable is y. So what I'm going to do is I'm going to need to write this as y minus k, this quantity squared, is equal to 4p x minus h. So that's the form I need to get A to look like. That means anything that is not y or attached to y needs to move to the other side of the equal sign. So I'm going to start out with y squared minus y is equal to, and then I have x minus 6. Now what I did was I left a blank because I know I'm going to have to complete the square. The reason I'm going to have to complete the square is because I need this to be y minus k, the quantity squared. To complete the square, I take this number in front of my linear term, in other words, in front of the y, which is negative 1. I divide it by 2, and I square it. So I add 1/4 here, and I add 1/4 here. On the left-hand side, this now becomes y minus 1/2, because it's a perfect square trinomial. On the other side, I have x, and then I have negative 6 plus 1/4. Well, negative 6 plus 1/4 is equal to negative 5 3/4. So negative 5 3/4, so minus 5 3/4. If you want to, you can write it as an improper fraction, but if I'm going to have to graph this, it makes no sense to write it as an improper fraction. Now, if I look at this, I have this part over here. I have the y minus k, the quantity squared, and I have some x minus h. I don't have any coefficient on x. That means, since I have no coefficient on x, that means that that p-value, that 4p value must be 1, because what I'm going to do is I'm just going to put parentheses around it. Now it's in the correct form, where the 1 is equal to 4p. That tells me my p is equal to 1/4. That means when I go to graph this, it's going to be a pretty narrow graph. So what I have so far is my vertex is at 5 and 3/4, 5 3/4, and 1/2. And that comes from, this is the H part of my vertex, and this is the K part of my vertex. So what I have for my vertex is I need to go to 5 3/4. So here's 5 3/4, and then I need to go up 1/2. So there's my vertex. This is 5 3/4, and this is 1/2. Now, remember, of course, I'm not drawing this to scale very well. My vertex is located there. My y is the part that's squared. That means that my axis of symmetry must go through the vertex, and it must be running parallel to the y or to the x-axis. So my axis of symmetry is y is equal to 1/2. Now, I know my graph is going to be opening to the right because my p-value is positive. My p-value is 1/4. So to find where my focus is going to be my h part, and in this case plus p, because I'm opening to the right. So this is going to be 5 3/4, and then I have to add my p-value, which is 1/4. So my focus, the x part of my focus, is at, I guess these aren't equal, this is just where I'm going to find it. So let me change these to arrows. So this is going to be at 6. So my focus is going to be at 6, and then the 1/2 didn't change. So my directrix, the way in which I'm going to find my directrix, in this case is going to be h minus p because I'm opening to the right. So my h is 5 3/4, and I need to take off my p-value, which is 1/4. And so my directrix is the line x is equal to 5 1/2. So at x is equal to 5 1/2. And so here's what my graph would look like. Again, this is not drawn to scale very well. Let's take a look at B. I'm paying attention to who is squared. Now, in this case, the thing that is squared is my x. So let me just get rid of some of this. The variable that is squared is my x. So I know that this thing is either going to be opening up or it's going to be opening down somewhere. And it's not necessarily going to be on the axis, but I do know the direction of it. Okay. So that means what I need to do is, like I did before, is I need to complete the square on the x parts. So I have x squared plus 6x plus some value is equal to moving the y over and then minus 10 and plus whatever that value is. The way in which I find this value is I take this 6, divide it by 2, and I square it. So that's going to be 9 and 9. The left-hand side gets factored into x plus 3, the quantity squared. And the right-hand side is y minus 1. Again, the form that I'm looking for is x minus some h squared is equal to 4p y minus some k value. As in my last example, there is no coefficient on y I need to factor out, so I can just put parentheses on it. So that tells me that my vertex for this example is at -3, 1. And my p here and my coefficient in front here are both positive. That means I know I'm going to be opening up somewhere. So I have the vertex at -3 and 1. So there's where my vertex is. I do need to figure out, I can do my axis of symmetry with no work. My axis of symmetry is x is equal to -3. I do need to still find my p-value. And so what I know, just with my previous example as well, that 4p has to equal the value in front of the linear part, in this case is y, so 4p must equal 1, so p must equal 1/4. So from my vertex, to find my focus, from my vertex, I need to add 1/4 to the y value because my axis of symmetry is x equals. That means my focus has to be on the x equals -3, which means x isn't changing. So I take 1, that's my y value of my vertex, I'm going to add 1/4 to it. So my focus, not drawn to scale again, is going to be at -3, 1, 1 and 1/4. Similarly, my directrix, to find my directrix, it's going to be 1 minus 1/4. So my directrix is y equals 3/4. So my directrix is y equals 3/4. This is just really not drawn to scale well. So y equals 3/4. So my graph is going to look something like that. All right. For these, we are going to find the equation given this information. I have, again, every time I have these, I always like to do a quick sketch of my graph because I like to know where everything is facing so I can decide who is the squared part and who is not the squared part. So on A, I'm just going to draw a quick sketch of where that is. My vertex is at -2, 3. So here's where my vertex is. They tell me my directrix is at the line y equals -3. So y equals -3 is where my directrix is. That must mean, because my directrix and my axis of symmetry must run perpendicular, that means that's where my directrix, or excuse me, my axis of symmetry is. So my axis of symmetry must be x is equal to -2. That tells me that I must be opening up, because I open up on the opposite direction of where my directrix is, because my focus is on the opposite direction of my directrix. The distance I traveled between my vertex and my directrix is my p-value. So in this case, I traveled a distance of 6. That means that I'd have to travel a distance of 6 to my focus. So I travel a distance of 6 to my focus. So my focus must be at the point -2, and then I'm adding 3 to the y value on my vertex, so it is at 6, or excuse me, I'm adding 6, so that is 9. So my graph is going to look something like this, not drawn to scale. They're asking for the equation, though. So because the fact that it is the the x that is squared, it must be in the form x minus h, and I wrote k, x minus h, the quantity squared, is equal to 4p x minus y. Y minus k. There we go. If I go slower, maybe I'll be able to do it without too much mistakes. So I know where my center it is. I know where my vertex is. It is -2, 3. So, and I have everything that I need now. So I have x plus 2, the quantity squared, is equal to 4 times p. We found our p to be 6. And then y minus 3. So the equation of our parabolic shape is x plus 2, the quantity squared, is equal to 24 y minus 3. So that is the equation for that first one. Okay, let's take a look at the next one. Like I said, I love to draw the picture, although they're not drawn well, not drawn to scale very well. I do like drawing the picture. So let's draw the picture for B. That way I know which way I'm facing. So, sorry, excuse me. Just not feeling well. So, pardon my coughing and clearing of my throat. Sorry, excuse me. My vertex is at 3, 2. So I'm going to go 3 and 2. So here's where my vertex is. My directrix is at -4. X is equal to -4. Because my directrix and my axis of symmetry must be perpendicular, that means that is where my axis of symmetry is. My axis of symmetry must pass through the vertex, and so this is the line y is equal to 2. The distance from the directrix to the vertex is my p-value, and from -4 to 2 or to 3 I traveled a distance of 7. So that is my p-value. And since my parabolic shape must be opening in the opposite direction of my directrix, my parabolic shape must be opening in this way. My focus must also be a distance of 7 from the vertex, so my focus must be over here. That means I'm going to add 7 to my 3, and so my focus must be at 10, 2. The equation in this case must have the form y minus k squared is equal to 4p x minus h. So, with all the information that I have, I can go right to the equation. It is going to be y minus 2, the quantity squared, is equal to 4 times that distance p, which was 7, and then x minus h. So y minus 2, the quantity squared, is equal to 28, x minus h. So there's that one. Let's do this very last one, and then we'll go into the applications of these. This last one, I'm going to draw pictures again. Now, when I draw the picture of this one, I'm going to scale it with pi. The reason I'm going to scale it with pi is because that's the measurements they're giving us. And by this point in our pre-calculus 2 class, we should be fairly comfortable with pi being just a number. So my vertex is at 0, -pi. So 0, -pi is where my vertex is. Sorry, excuse me. My focus is at 0, -3pi. 0, -3pi. That tells me that my graph is opening down because my parabolic shape has to hug my focus. So the distance between my vertex and my focus is p. I have traveled a distance of 2pi. So that means from my vertex to my directrix, I must also travel a distance of 2pi. That means that my directrix is at y equals positive pi. I have everything I need to build the equation. This equation, because I'm opening up or down, is of the form x minus h, the quantity squared, is equal to 4p y minus k. So my x minus h is going to be x minus 0. So x minus 0, the quantity squared, is equal to 4. The distance I traveled from my directrix to my vertex, or my vertex to my focus, was 2p. But because it is upside down, it's opening down, I must have a negative 2p here to get my directionality correct. And then it is y minus, and then my k value is pi. So my final answer is x squared is equal to -8 pi y minus pi. And so that's my final answer for this one. So let's take a look at the applications here. We're going to start with the spotlight. It has a parabolic cross section that is 4 feet wide at the opening and 1.5 feet deep at the vertex. How far from the vertex is the focus? So we're going to draw a picture because I love drawing pictures. I'm not good at it. Maybe if I do a bunch of them, I will be good at it. But I don't believe that. I know I'm still not going to be good at it, but I still like drawing pictures because I can mostly. Okay, so let me just clean this up a little bit. And what they're telling us is I'm going to draw it so that I am putting my vertex right here because it makes my life the easiest. I'm going to put it right here at the origin. And I'm also going to do it so it's opening up so I can go to using this equation, which is x squared is equal to 4py. I'm going to use that equation. If I read through the application, it tells me that my parabolic shape is 4 feet wide at the opening, so from side to side is 4 feet. And it also tells me that the depth is 1.5 feet. So with that information, we know that there's a point right here on my parabolic shape is 1.5 comma 2. The reason it's 2 is because the distance from the y-axis to the corner of my spotlight must be half of the width. And so that's why I know it's 1.5 comma 2. Now I have x and I have y, which is something different than what I normally have. That means I have a replacement for x and I have a replacement for y, and what I'm chasing is the p. So 1.5 squared is equal to 4p, because that's what I'm really chasing, times y, which is 2. I get my calculator out, and I've got 1.5 squared is 2.25 is equal to 8p. I'm going to divide both sides by 8. And so I've got 2.25 divided by 8 is equal to p. Now, I get my p value, which is equal to 0.28125 feet. So to answer the question, how far is a vertex from the focus? Well, it is 2.28125 feet from the focus. Let's take a look at our last example, which is the suspension bridge. We have cables of a suspension bridge are in the shape of a parabola. The towers supporting the cable are 600 feet apart and 800 feet high. If the cables touch the road surface midway between the towers, what is the height of the cable of the road when it's a point 150 feet from the center? So when I draw my picture, if I decide that I want to draw my bridge so it looks like this, I absolutely can do that, right? So I can have my edges here. I can totally do that. So here's what it looks like. But that is not the most convenient way to solve this. It's going to add extra steps I don't necessarily want. So rather than drawing it like this, I'm going to put my y-axis right through the center there so that I can use the equation in the easiest form, which is of the form x squared is equal to 4py. Again, it doesn't matter. It's just this one's going to be a lot less work. The reason I know it's going to be a lot less work is because I can use the information just like I did in my previous example. The towers are 600 feet apart. That means one tower must be 300 feet from where I placed the axis of symmetry. I also know that the tower is 80 feet high. That tells me this point is the point 300, 80. And just like my previous example, is I'm going to use that information to find the p-value, because I need to find the equation so that I can find out what the height is at 150. So I actually do need to find the equation for this. I have replacements for x. My replacement for x is 300. And then for p, I have a replacement for y. Y is 80. And so I have 300 squared, which is 90,000, is equal to, and then 4 times 80 is 320 p. Solving for p, I get my trusty calculator out. And I get 281.25 for p. Now, I have the equation x squared is equal to 281.25 multiplied by 4, because this value that I found was my p. It's p multiplied by y. I want to know what the height of the cable is when I'm 150 feet from that point in which we touch the ground. So I have 150, that's my x value squared, is equal to 281.25 multiplied by y. So I get my calculator out, 150 squared divided by 4 multiplied by 281.25. And so my answer is 20. Because this is an application, so it is 20 feet. The cable, let me just do this. My answer is the cable is 20 feet from the road. 20 feet high from the road. And that is section 7.3, parabolic shapes.